Hello students, in this video we'll be solving question 6 from exercise 7.1, and the question says name the type of quadrilateral formed, if any, by the following points and give reasons for your answer. Now, before we solve this problem, let us first have a look at how we can come to the decision of what type of a quadrilateral the points form. Okay, our first quadrilateral is a square where we need to show four sides are equal and the diagonals are also equal. In other words, if we are given 4 points A, B, C, D, and those are the coordinates, some coordinates are given for them. Okay, like for example here this will be x1 comma y1, x2 comma y2, x3 comma y3, and x4 comma y4. There will be some numbers in place of this x and y. We need to show this AB is equal to BC is equal to CD is equal to AD for a square. Not only that, we also need to show that their diagonals are equal. Which are the diagonals? The one which connect the two vertices, opposite vertices. So we need to show that BD is equal to AC. That is the criteria for a square. Okay. Now, you may recall from your class 9 what are the different types of quadrilaterals. In class 9 we learnt about 6 main types of quadrilaterals. They are square, rhombus, rectangle, parallelogram, kite, and so forth. Okay, all these, if you don't remember them, not to worry. I have got a video that I've done for class 9, and the link to that is in the description box below. You may go click on that link and go to the video which actually describes the 4 and differentiates the 6 main types of quadrilaterals. Just for your knowledge, for your information, it can come in handy with respect to other chapters as well. But for now, I'll be listing the quadrilaterals that have a possibility of coming for the exam and what we need to show in order to arrive at the decision what type of a quadrilateral this is. So this is square. Let's go to the next one, which is rhombus. In case of a rhombus, we need to prove or show 4 sides are equal. See, mind you, what we are showing over here, for example square, we are showing 4 sides equal, diagonals are also equal, and rhombus 4 sides are equal. These are not the only properties which prove them square or rhombus, but for our chapter, what we are doing right now, coordinate geometry, to show this much is more than enough to prove that particular figure, 4-sided, closed 4-sided figure or polygon is actually a square or rhombus or some other quadrilateral. Let's move to the next structure. The next one is rectangle, where we need to show opposite sides are equal and diagonals are also equal. Difference between a rectangle and square in what we need to show is all sides are not equal in rectangle. In case of square, all sides need to be shown equal, whereas in rectangle it's enough to show opposite sides equal and diagonals also equal. Next is a parallelogram, where we just need to show the opposite sides are equal. Now, to differentiate between parallelogram and a rectangle, to show that it is a parallelogram but not a rectangle, apart from showing that it is opposite sides are equal, we also need to show that the diagonals are not equal, because if the diagonals are equal, then it becomes a rectangle. Similarly, if we need to show that the structure, the given quadrilateral is a rhombus but not a square, we need to show, apart from showing that all sides are equal, we also need to show that the diagonals are not equal, because in a square the diagonals are also equal apart from the 4 sides being equal, similar to a rhombus where 4 sides are equal. Both square and rhombus, 4 sides are equal, but in square the diagonals are also equal. So now coming to the question which says name the type of quadrilaterals formed. We need to use the knowledge that we have just acquired to show the type of quadrilaterals that are being formed in the given problems under question 6. So let's go to the first problem. The first problem gives us 4 points: -1, -2, 1, 0, -1, 2 and -3, 0. Let us give them some letters so that we can show their combination, the pairs. So we'll say let A -1, -2, B 1, 0, C -1, 2 and D -3, 0 be the given points. Therefore, you can say x1 will be -1, y1 will be -2, x2 will be 1, y2 will be 0, x3 will be -1 and y3 will be 2. Put the semicolon over here here too, and x4 will be -3 and y4 will be 0. Let's begin with different combinations. So what are the different combinations? We list the num first: AB, BC, CD and DA. For AB, we will put the formula x2 minus x1 whole square plus y2 minus y1 whole square. For BC, it will be x3 minus x2 whole square plus y3 minus y2 whole square. For CD, it will be x4 minus x3 whole square plus y4 minus y3 whole square. And finally for DA, let's put it slightly low. It will be y1 minus y4 whole square plus, it should begin with x, so x1 minus x4 whole square plus y1 minus y4 whole square. Okay. Now that we have put down the formulas, let's just substitute their values for each one of them and find out how much do we get for AB, BC, CD and DA. Beginning with AB, x2 is 1 minus x1, which is -1 whole thing in brackets raised to square, plus y2, which is 0, minus y1, which is -2. So minus of -2 whole thing raised to square, equal to minus and minus will give us plus. So 1 plus 1 gives us 2. So 2 whole square plus minus and minus gives us positive 2. 0 plus 2 gives us positive 2 whole square. 2 raised to square is 4. 4 plus 4 gives us 8. Okay, so I'll put it down as 4 plus 4. 4 plus 4, that gives us square root of 8, which we can write as 2 root 2. Next, BC, x3 is -1 minus x2, which is -1 raised to square, plus y3 is 2 minus y2, which is 0 to square. Minus 1 and minus 1 gives us minus 2. 2 minus 0 is 2 whole square equal to minus 2 whole square is 4 plus 2 whole square is also 4. That gives us the square root of 8, which is equal to 2 root 2. Next is CD, beginning with x raised to 4. X raised to 4 is minus 3. Cancel this part. X4 is minus 3 minus x3, which is minus 3, minus 1 whole thing in brackets raised to square, plus y4, which is 0, minus y3, which is 2 raised to square. So minus and minus gives us plus 1. So minus 3 plus 1 gives us minus 2 whole square, plus 0 minus 2 gives us minus 2 whole square. This will be 4 plus 4. It gives us square root of 8, which is can be equal to 2 root 2. And then we have dA. So that is x1, which is minus 1, minus x4, which is minus 3, so minus and minus 3 whole thing raised to square, plus y1, which is minus 2, minus y4, which is 0. Well, minus and minus gives us positive 3. Positive 3 minus 1 gives us positive 2 square, and here this will be minus 2 whole square. Forgot to put the square here. That gives us 4 plus 4 equal to square root 8, which is equal to 2 root 2. So which means now we have got AB equal to BC equal to CD equal to DA. Clearly you can see they are all equal to each other. So if we were to plot these points, it would be something like this, with A, B, C and D like this, and these four sides are all equal to each other. Now this can be a square or this can be a rhombus, and to prove that this one is a square or rhombus, to differentiate between the two, we'll have to check their diagonals, which is AC and BD. If AC is equal to BD, then these points are part of a square. But if the diagonals are not equal to each other, then these points are part of a rhombus, where all sides are equal but diagonals are not equal. So now let's check what is AC and BD. So if see whether we are checking now to see whether AC is equal to BD. So AC and BD. A and C, which means the formula has to be C. How do we know which one comes first, which one comes next? It's quite simple. You just follow in any direction whether you take, it should come same. What I mean to say is, now this would be, you are taking a combination between A and C, which is x1 comma y1, and this is x3 comma y3. It doesn't matter whether you take x1 minus x3 or x3 minus x1, because ultimately what happens, it comes, the whole thing comes in a bracket which is raised to square. So either you will get positive or you will get negative. If you get negative with the square, this negative sign goes, so it doesn't really matter. Okay, but you should be careful which points you are taking. So if it is AC, then the combination is going to be with x1 and x3. So if we take x1 minus x3, okay, raised to square, then the same way we have to write y1 minus y3. So I am taking 1 and 3 because we are talking about A and C, and C corresponds with x3 comma y3. Similarly, when we speak about BD, then it will be between this one and this one, and this is what x2 comma y2, and D is x4 comma y4. So if we take x2 minus x4 raised to square plus y2 minus y4 raised to square, it is okay. You can take other reverse way as well, x3 minus x1, but if you write x3 minus x1, then this also has got to be y3 minus y1. Similarly, over here you can write x4 minus x2, then this also has got to change to y4 minus y2. Okay, just remember the sequence. AC. So now that we have decided what is the sequence, let's just substitute the values and see what we get. x1 is minus 1, minus x3, x3 is here, so minus 1 minus of minus 1 whole square in the bracket plus y1 is minus 2 minus y3, which is positive 2, so there will be minus 2 whole square. So this becomes minus and minus will give us positive 1 and negative 1 gives us 0, so 0 whole square plus minus and minus 2 gives us minus 4, minus 4 whole square. This will give us 16, which is equal to 4. Let's check what is BD. x2 is 1 minus x4, which is minus 3, so minus of minus 3 square plus y2, which is 0 minus y4, which is also 0 whole square. So minus and minus gives us positive, so positive 3 plus positive 1 gives us positive 4 whole square plus 0 whole square, that gives us square root of 16, which is equal to 4. So this clearly shows you, so you can say thus AB is equal to BC equal to CD equal to DA, and diagonals AC and BD are also equal to each other. Therefore, the given points form a square, okay, because all sides are equal and their diagonals are also equal. So therefore you can say, or you can say this implies quadrilateral ABCD is a square. Okay, so I hope you have got this thing. Just make sure that you do not make mistakes while taking the values of x1, x2, x3, x4 and y1, y2, y3 and y4, okay, while substituting, because if you do a mistake then you may get a wrong answer. Okay, so this is how we prove such type of problem. Let's go to the second problem. Once again we'll assume the 4 points as A, B, C and D and check whether which type of quadrilateral these points form. So let us begin. First one, we'll assume A, B, C and D for each of these points. So we say let A minus 3 comma 5 B 3 comma 1, C 0 comma 3, and D minus 1 comma minus 4 be the given points. Okay. Next takes therefore x1 comma y1. Okay, or we just say x1 equal to minus 3, y1 equal to 5, x2 equal to 3, y2 equal to 1, x3 equal to 0, y3 equal to 3, and x4 equal to minus 1 and y4 equal to minus 4. Okay, so now let's list down the 4 pairs AB, BC, CD and DA. AB equal to x2 minus x1 whole square plus y2 minus y1 whole square. BC will be x3 minus x2 whole square plus y3 minus y2 whole square. CD will be x4 minus x3 whole square plus y4 minus y3 whole square, and DA would be x1 minus x4 whole square plus y1 minus y4 whole square. And now we'll substitute the values of x and y for each of this to see what are the values we get for AB, BC, CD and DA. First we'll begin with AB. X2 is equal to 3 minus x1 which is minus 3 whole thing in bracket raised to square plus y2 which is 1 minus y1 which is 5. So 1 minus 5 whole square equal to minus and minus gives us positive 3. So 3 plus 3 gives us 6. 6 whole square plus 1 minus 5 gives us minus 4 whole square. That will be equal to 6 square is 36 and minus 4 whole square gives us positive 16. That comes to 52. Leave it at that. Then next we go to BC. X3 is 0 minus x2 which is 3, minus 3 whole square plus y3 which is 3 minus y2 which is 1. 3 minus 1 whole square. That gives us 0 minus 3 whole square gives us minus 3 whole square plus 3 minus 1 is 2 whole square. Next, minus 3 whole square gives us 9 and plus 2 whole square gives us 4. We square root 13. Next is CD. X4 is minus 1 minus x3 which is 0 whole square plus y4 which is minus 4 and y3 is minus 3. So minus of minus 3 whole square equal to minus 1 whole square will remain here plus minus and minus gives us positive 3. So minus 4 positive 3 gives us minus 1 whole square. That will be minus 1 whole square is 1 and plus minus 1 whole square is also 1. So 1 plus 1 square root of 2. Finally we have DA. See what do we get here. So we have x1 which is minus 3 and x4 which is minus 1. So minus of minus 1 whole thing square plus y1 which is 5 minus y4 which is minus of minus 4 whole thing raised to square, and we get minus and minus gives us positive 1. So minus 3 plus 1 gives us minus 2 whole square plus minus and minus gives us positive 4. So 5 plus 4 gives us 9 whole square equal to minus 2 whole square gives us 4 and 9 whole square will give us 81. So that comes to 85. So clearly from these four values we can make out that none of the quadrilaterals that we know are formed. See, because if it says name the type of quadrilateral formed if any, but from the values that we can say these are not matching, so we can easily say that no quadrilateral, since AB is not equal to BC is not equal to CD is not equal to DA. This implies that no quadrilateral is formed. Okay, so no quadrilateral is formed. We don't need to look into this further. You just need to show that sides are equal or not equal. If they are not equal, then no quadrilateral is formed. If they are equal, then we have to see which quadrilateral it is. Let's move to the next problem. Coming to the third and final problem under question 6, we need to find whether this set of points that you see in front of you, do they actually form a quadrilateral? If yes, then what type of quadrilateral? Let's check it out. So let A 4,5, B 7,6, C 4,3 and D 1,2 be the given points. Next, so therefore you can say x1 equal to 4, y1 equal to 5, x2 equal to 7, y2 equal to 6, x3 equal to 4, y3 equal to 3 and x4 equal to 1 and y4 equal to 2. So we have AB, BC, CD and DA. AB is equal to x2 minus x1 whole square plus y2 minus y1 whole square. BC is x3 minus x2 whole square plus y3 minus y2 whole square. CD will be x4 minus x3 whole square plus y4 minus y3 whole square, and finally DA will be x1 minus x4 whole square plus y1 minus y4 whole square. Let's begin with AB. x2 is 7 minus x1 which is 4 whole square plus y2 which is 6 minus y1 which is 5 whole square. See what we get. 7 minus 4 is 3 whole square plus 6 minus 5 is 1 whole square equal to 9 plus 1 which is equal to square root of 10. Next, BC. x3 is 4 over here minus x2 which is 7 whole square plus y3 which is 3 minus y2 which is 6 whole square 4 minus 7 gives us minus 3 whole square, and 3 minus 6 gives us minus 3 whole square. There's a positive sign in between. Then minus 3 whole square gives us 9, and minus 3 whole square again gives us 9. So that will be square root of 18. Right. Let's go to the next one, that is CD. x4 minus x3. x4 is 1 minus x3, which is 4 whole square, plus y4 is 2 minus y3, which is 3 whole square. That gives us 1 minus 4 gives us minus 3 whole square, plus 2 minus 3 gives us minus 1 whole square. That is equal to minus 3 whole square gives us 9, minus 1 whole square gives us 1, square root of 10. Finally, we have dA, x1 minus x4. x1 is 4 minus x4, which is 1, or minus 1 whole square, plus y1, which is 5, minus y2, which is 2 whole square. That gives us 4 minus 1 is 3 whole square, plus 5 minus 2 is 3 whole square. That gives us 9 plus 9 equal to square root of 18. Now clearly you can see that AB is equal to CD and BC is equal to DA. So if we draw a figure like this, A, B, C, D, we have AB, which is equal to CD. This side is equal to this side, and we get BC, which is equal to DA. So BC is equal to DA, which means opposite sides are equal. Now when opposite sides are equal, it can fall into two categories. Either it is a rectangle or it can be a parallelogram. The difference between the two is that in a rectangle the diagonals are equal, whereas in a parallelogram the diagonals are not equal. So we'll have to check whether the diagonals are equal or not to arrive at a decision whether the now so called points, which we have now confirmed it is definitely a quadrilateral, whether it is a rectangle or a parallelogram. So now let's check the diagonals, which is AC and BD. So AC and BD. AC will be, this is x1 comma y1, and this is x3 comma y3. So take x1 minus x3 whole square plus y1 minus y3 whole square. Let's see what we get. 4 minus 4 whole square plus 5 minus 3 whole square. 4 minus 4 is 0 whole square, plus 5 minus 3 is 2 whole square. That gives us 4, which is equal to 2. Let's check for BD. B will be x2 comma y2 and D is x4 comma y4. We'll take x2 minus x4 whole square plus y2 minus y4 whole square. x2 is 7 minus y4 is 1 whole square plus y2 is 6 minus y4 is 2 whole square. 7 minus 1 is 6 whole square plus 6 minus 2 is 4 whole square. That gives us 36 plus 16, which is equal to 52. So clearly AC is not equal to BD. So you can say from the above, AB is equal to DC and AD is equal to BC. but AC is not equal to BD. Therefore, the given points form a parallelogram. You can say therefore AB quadrilateral ABCD is a parallelogram. Okay. So this is how we solve such problems. And that's all in this video. If you have liked watching the video, please click the like button, share it with your friends and classmates. Please subscribe to the channel and do not forget to click on the bell icon to receive notification whenever new video is posted. Thanks for watching. See you in the next video.